Introducing the Ultimaker Factor 4, industrial grade performance with reliable and repeatable results. Streamline production, simplify processes, and keep your operations running. Featuring onboard print process reporting, direct dual extrusion, and engineering-grade materials, Factor 4 achieves unrivaled predictability and minimal variance. Precise temperature control across the build envelope, a triple insulated build chamber, and built-in HEPA filter ensure consistent production output on complex and challenging designs. Its H-bridge gantry and direct drive head enable rapid dual material printing. Factor 4 is capable of reaching up to 340 degrees Celsius on its print cores, 70 degrees Celsius on the print chamber, and 120 degrees Celsius on its heated bed. Factor 4 redefines the standards of 3D printing in manufacturing environments. Its conspicuous red stop button ensures easy and safe operation should there be a need to immediately halt printing. An integrated material handling system allows engineers to print consistently and confidently with a variety of durable and high-performance materials, ranging from the new PPS-CF to fully flexible low-Shore-A polymers, all while integrating seamlessly with Cura and major AM software platforms. Tested to achieve over 95% print success rate, Factor 4 delivers consistent results across multiple machines. After each print, it provides an in-depth report, offering comprehensive insights into each print job. Ultimaker Factor 4. Industrial-grade performance, reliable and repeatable results.
You asked, and we listened. Our most popular printer just got even better, packed with our users' most requested features. Introducing the Ultimaker S7. The S7 builds on the Ultimaker's already remarkable 3D printing reliability with new features, such as an inductive sensor that allows for improved automatic bed leveling, and an integrated air manager for excellent environmental control right out of the box. All of this means that you can start a print and walk away, safe in the knowledge that your first layer will print perfectly. And for those times when you want to be sure, a new higher quality camera means you can monitor your prints from anywhere. And once your print's done, the flexible build plate means you can remove your print and start a new one in seconds. And an innovative build plate sensor, combined with placement pins, means you never have to worry about forgetting or misplacing your build plate before printing. All of these improvements make for our most reliable 3D printer ever, while maintaining access to the full Ultimaker ecosystem and hundreds of compatible materials. Explore more applications with a new level of print success.
なんか初期の頃からなんかどんどんユーザーがこう広がってるというか膨らんでるというか広がっているなっていうのはこうやっぱりリアルに感じることができるので、ちょっと親心じゃないですけどとても嬉しく思います。まあやっぱりスケッチとリアルとやっぱりどうしても乖離がある。でもそこにこう間にやっぱ 3D プリンターとかが入ると一気になんかそこのお客さんとのコミュニケーション、他の人とのコミュニケーションが解像度が一気に高まるっていうのが質感が高まるっていうのが 3D プリントの
業界全体が盛り上がっていくのがなんかすごく大事かなと思いました。なので何か工場内で新しいことをやりたいとか作りたいとかまず 3D プリントから検討してるんですよ。でそれができないからじゃあ切削しようとか、まずは 3D プリント。
6台フル稼働していて、でも順番待ちみたいな状態なので、かなりやっぱり使われるようになったなっていう、本当に今年に入ってだいぶ数が伸びてきたなという感じはありますね。3D プリンターとかそのデジタルファブリケーションのその演習っていうのも、去年からやり始めたんですね。それでそこでこう学んだ学生たちが結構使い始めたっていう、でそれがまたさらにこう後輩に波及してきたっていう感じなので、だいぶ定着してきたなっていう感じはありますね。
ますと、教育向けのユーザーが多い機種になっていますので、まだ教育向けに特化した内容だったりとか、教材っていうこのワースペースをですね、ちょっと外に向かって開放できる、ネットで開放できるように使っていきたいなと思っているところでもありますので、こういうイベント開催できて非常に良かったと思います。
Introducing Form 4. So fast, it will change the way you work. With most prints in under 2 hours. Iterate several times a day. With a proprietary release texture, flexible film tank, and ultra-high optical power. Produce parts that always fit, rivaling injection molding with 50-micron pixels, advanced pixel smoothing, and light touch supports. Achieve an unmatched print success rate with validated print settings, precision heating, force sensing, debris detection, and remote monitoring. Tackle any problem with industry-leading materials. With an upgraded mixer and dispense system that support highly viscous and filled resins. And do it all with a workflow anyone can learn in 15 minutes. With instant material changes, comprehensive software, and automated post-processing. Enter a new era of performance, built on our next-generation low-force display print engine, featuring a high-power backlight unit, light processing unit 4, release texture, and a flexible film tank, delivering extreme speed, reliability, and print quality. Now, anyone can perfect their products, keep production running, or improve patient care. The tool you've been waiting for, Form 4.
Design and manufacturing workflows are closer together than ever, but our ideas still often exceed what we can physically realize. A new wave of independent manufacturing starts now with the Fuse One, an affordable, compact SLS 3D printer with an intuitive workflow. Selective laser sintering, or SLS 3D printing, is relied on for printing strong, functional nylon parts. In the past, SLS has been too expensive and difficult to use for many businesses. The Fuse One allows you to fabricate production-ready parts and high-performance prototypes. Control your entire process from iterating on your first concept design to manufacturing finished products. The process starts in Preform, our print preparation software. Preform's part packing algorithms can automatically arrange many models in a build. During setup and printing, the Touch UI walks you through every step. Monitor your print from the touchscreen or from your computer via the integrated live camera. Once your print is complete, transfer the build chamber to the Fuse Sift. This safe, efficient powder recovery station completes the workflow. Fuse Sift will automatically dispense and mix used and new powder after you set the ratio. Reduce waste by recycling powder at a 30% material refresh rate. This means you can print with up to 70% recycled powder. After you've transferred a completed build to Fuse Sift, swap out the entire build chamber from the Fuse One for non-stop printing. SLS 3D printing fuses nylon powder layer by layer. The unused powder supports the parts during printing, so you can create complex, interconnecting designs with no need for support structures. Nylon parts balance strength, flexibility, and detail, so prints are ready for rigorous functional testing or to ship ready-to-use products to customers. It's time to rethink product development and take control of your own manufacturing. The Fuse One, Production SLS, finally within reach.
Imagine cars and planes becoming lighter and more fuel efficient. Dental restorations more functional and long-lasting. Imagine spare parts printed on demand within minutes at your local hardware store. Introducing LSPC. With the affordable Nexa 3D printer, manufacturers will be able to design and produce new items faster and more efficiently. Consumers will gain by being able to order up custom items that previously would have been prohibitively expensive. Industrial manufacturing, automotive, aerospace, dental, rapid prototyping, athletic footwear. It's time to upgrade your speed, performance, precision, capacity, and economic. Nexa 3D. Upgrade additive manufacturing.
Designed as an end-to-end solution, the Studio System is the first and only to deliver office-friendly metal 3D printing. The three-part system, the printer, debinder and furnace, integrates with secure web-based software to deliver a seamless workflow to go from digital file to sintered part. Fabricate software constructs build plans from STL or native CAD files. Based on the user-defined parameters, material and part geometry, Fabricate automatically adjusts the design for part shrinkage, constructs advanced supports, and determines optimal orientation. The user can interact with the part and view precise toolpaths through a dynamic interface. It then creates a unique build plan and identifies compatible parts from the queue that can be fabricated together. The system brings a wide range of critical alloys to 3D printing. Each alloy undergoes rigorous qualification by world-leading material scientists, whose expertise is at the core of the Studio System technology. Safe to handle, hot swappable media cartridges and quick-release print heads allow for easy material changes in a matter of minutes instead of hours or even days with other systems. In a process called bound metal deposition, metal rods, metal powder held together by wax and polymer binder, are heated and extruded onto the build plate, shaping the part layer by layer, similar to an FDM printer. The printer features automatic extruder calibration and bed leveling, based on a software analysis of the parts to be printed. There are two extruders, one dedicated to printing metal, and the other for an interface layer printed between the part and its supports. With no loose metal powder or hazardous lasers, this process eliminates safety requirements often associated with metal 3D printing, while enabling new features like closed-cell infill for lightweight strength. During the print, a removable print sheet is held in place by the vacuum bed beneath it, providing a smooth, secure platform. Once the print is complete, the vacuum disengages and the print sheet and part are easily removed from the printer. The flexible sheet is designed to allow for easy removal of the part without damaging it during transfer. In the debinder, the parts are immersed in fluid. As primary binder is removed, an open pore structure is formed throughout the part in preparation for sintering. With a low emission design, it requires no external ventilation. Automatic fluid distillation and recycling means there is no need to refill between each cycle. Once the cycle is complete, the parts are ready to go into the furnace. No protective gear or drip dry required. Fully automated and sized to fit through an office door, the furnace delivers industrial strength sintering in an office-friendly package. The furnace features two onboard gas canisters that are easily removed and equipped with RFID tracking devices. It is equipped with a disposable binder cold trap liner for safe and easy disposal of binder removed during sintering. Built-in temperature profiles are tuned to every build and material to ensure uniform heating and cooling. Heated to temperatures near melting, remaining binder is removed and metal particles fuse together, causing the part to densify up to 96 to 99.8%. Designed to simplify post-processing, the ceramic release layer printed between the part and its supports doesn't bond to the metal, enabling separable supports that are easily removed by hand. The result is a near net-shaped part with the strength, accuracy and resolution needed for functional prototyping. The Studio System brings metal 3D printing to the engineer, providing the only safe, cost-effective, and easy-to-use solution for printing complex metal parts in-house.
You are now in the Shop Lab. The Shop Lab is designed to be a mini factory to continuously exercise the shop system, printing hundreds of parts a day for ourselves and for our customers. So the shop system is the first metal 3D printer designed specifically for machine shops, allowing shops to enter into additive metal manufacturing like never before. The shop system is a single pass, high-resolution metal binder jetting system at a price point that has never been achieved before. The shop system is an extremely easy system for machine shops to learn to use. Powder is loaded into the printer, and the printer autonomously lays down 50 to 100 micron layers of metal powder and prints batches of parts. The customer can load as many different parts as they would like into that batch, and it does not change the time. The printer then ejects that batch of parts, which can move on to the next station, and the printer can begin another batch of parts. The next step in the shop system is the depowder station. Now, the shop system is a batch process, which means a batch of parts can be printed, and then that batch can be moved on to the depowder station, so another batch can then be printed at the same time. The depowder station is a fully integrated depowdering station where parts can be excavated from the powder, and that powder can be fully recovered in the integrated recovery system. Those parts, once excavated, can be placed directly into the desktop metal furnace for full sintering. Sintering technology has evolved over the years to be huge furnaces that cost hundreds of thousands of dollars and take up entire rooms like this. But what we've been able to do here at Desktop Metal is shrink down that same technology into a small furnace that is vacuum capable, partial pressure capable, and can roll through a door. And the shop system is designed to scale manufacturing from small scale to medium scale to enhance a machine shop, whether it's an external machine shop or an internal machine shop, with 3D printing capability.
The Extreme 8K is the world's largest production-grade DLP printer, featuring two powerful DLP projectors that are mounted up top and project downward. This enables us to deliver a 17-inch by 14-inch build area that enhances the scale of DLP production. That is important because it enables lower costs per part. This printer is designed specifically for volume production of functional end-use parts and products. Adding on to the economic value is the fact that this printer is an outright capital investment as opposed to an annual lease that extends out into perpetuity. That annual lease would prevent you from experiencing the improvements of cost after depreciating the printer.
Freefoam is a first-of-its-kind 3D printed foam. This breakthrough material can be 3D printed in virtually any shape and size. After printing, you simply put it in an oven, where small air pores expand to a specific size that can be tightly controlled. It sounds simple, but this innovation is about to rock the foam industry. Every year, more than 1.5 billion pounds of foam are produced for bedding, furniture, seating, sporting goods, and more. It's an industry that touches all of us every day. It's also an industry full of problems. Most foam products start in a big expensive tooling mold or as a block at a factory. Later, it's cut to shape, held back by design limitations and creating tons of waste. It's also bulky and heavy to transport. It absorbs water. It doesn't allow for good air circulation. But now, Free foam allows manufacturers to 3D print a foam design in the exact shape with the softness or hardness they desire. Because it's a true foam with closed air cells inside, it's lighter and less bulky than traditional foam, or even other 3D printed lattice designs that try to replicate foam. What's more, free foam can offer the same or even better performance. With development underway with major manufacturers, free foam is already on its way to changing the way foam is made at production volumes. Free foam can be 3D printed and shipped in a compact form and expanded close to the point of final use, helping to eliminate shipping costs and fuel consumption. Come touch the future. It's free foam.
我々東京大学工学系研究科の中で、研究室のですね、例えば実験装置であったりとか研究材料であったりとかっていうのをですね、試作する、部門だったんですね。産学連携であったりとか外部の企業さんと一緒にやっていくっていうことが大学全体で求められていく中で、3D プリンターの代理店であるブルレー様と、共同でですね、最新の機材を揃えて、学内外に使ってもらうような設備を作ろうと。
従来のものづくりとうまくミックスするような使い方というところが大事になってくるかなと思っています。東京大学さんのエキスパートの方の各分野でのものづくりの知識とミックスすることで 3D プリンターを使った最新の新しいものづくりっていうのがご提案できるのではないかなというふうに考えております。
一番、多い相談としてはこういうものが作りたいんだけれどもどうやって作っていいのかわからないっていうのを逆に 3D プリンターが最適だと思えば、こういう機種を使えばできますよと。作りたいイメージから実際に作りたいものでできたものまでの、中間をつなぐようなところを、我々の方で相談に乗らせていただいています。
それに伴いましてやはり3D プリンターで、十分な効果が発揮できるような、設計からですねディーファムっていうんですけども、そういったところから、変えていくような形が必要になってくるのかなと思っております。
適切な教員の方をですね、学内でご紹介させていただいて、このセンターを活用しつつですね、研究開発にですね資するような形につながっていければなというふうに考えております。